Okay. This is the basics, some few programmings I have already written here, and previous classes already we have also discussed about these programmings. So just have a basics concept, then we will go for the entire thing that today we have to close the Haskell. Okay. So now, till now I have given some questions and the previous classes also I have given some questions to all of you. So anybody who has done the programming? Don't sir.
Sir, I have not started because
Okay.
I will do this in this week.
Yeah, the previous weeks, the previous week. So I've given a lookup programming, the lookup function. So I've already told the program. I've also showed the program actually how we are going to run the program in the lookup or in a database how it's working. Okay, just forget it. So last part we'll discuss in the last one. So now, so we already know that Haskell is a purely functional programming language. Till now we have already completed. I just remind you everything. So before I'm going to start it, so here you can see that these are the things. Till now we know that what is a model. Anybody who can tell me what is a model? What are the models we have already covered? What is the difference between the list and the tuple? Don't sir? Aditya sir?
No, sir, no precedence are existing.
Okay. Okay. So just I'm showing you. Now you can see that this is basically a list model. So model means what? Till now, whatever the functions, whatever things we are developing the applications, we have to call a small programmings into a another program, just like we are defining a predefined functions. So that function is defined inside a user defined, then we have to call into a another programming that is defining called as a model. A small part means whenever you are writing a small part of the program. Such that, for example, take an example that you are writing a factorial. You write the factorial and save it in the name of x.hs. Then you write a main programming that x.main programming. Then you compile it and you have to import that file to the main programming. So before that, I'm showing the example. Just I'm giving the simple programming just like list model. This is the models, whatever you are writing here. So now here, what you can see that we have imported some of the predefined functions. You can see here intersphere, intercalculate, split art, sort programming. These are the predefined functions which has been defined inside the data list. So that's why we have to import the data list to get the output of this program. Okay? Okay, all of you?
Yep.
Now, I'm just going to run the program. Now you can see that here, whatever may be the output, it's not a mandatory, but you can find out that intersphere, what is the functionality of this, it will work. Then intercalate is a function, it is using as per the requirement. Split at 7, it will work according to the requirement. Sort is another function, it is work according to the function. Everything is defined inside the data list. So you have to import the data list to execute the function because we have not written the entire functionality of the interface. This is the part we have already know in C, C++, Java, .NET, everywhere. So here we are using this. So what is this functionality? This is the most important called as the test model. So module means we have written a small part of the programming, then saved in a particular file name, then we have to call that into my module. So the list is one of the data list is one of the module where it has been defined all these functions, because I'm going to show you how to create a user-defined model. So before that, we should know what is the predefined models. Now, you can see that what is the interspace output here? What is giving here? I'm writing that Cardano India Developer Community. It's a complete string. And the functionality of this one is it will give each character with a dot. Now you can see the below output. C
Yes.
dot A dot R dot D dot A dot N dot O dot IO, everything is mentioned. This is the functionality of this, because whenever you want to do some operation, we should know what is the functions, what is the functionality of that function, so that it will give us the output. Now you can see that I define a string. Let's start with Haskell. Then what you can see that I've defined this is a array list. Okay, so let's is within a string, start is a another string, with is another string, Haskell is another string, and defined with a comma. That means it is defined inside a list. So here what you can see that intercalate is defining that just take the array list and define it as a single string. Here you can see that it defines with a single string. Means it combines all that elements of that array and make it a string. So this is called as a let's start with Haskell. Okay, all of you? Hello.
Yes, sir.
Yes.
Yes, Professor.
Okay.
Yes.
So just because I'm just making you interaction there, it is not that what we are reading it. It is not that what we are going to that, yes, this function is this function, because there is thousands of functions are there. Time to time, whenever you utilize it, then we can get the what is the functionality of this. Because whatever language till now we have covered, C, C++, Java, .NET, Python, whatever things, everywhere there is lots of functions. Whenever we have an experience, then we can know that yes, this is the function utilized, this is the function for use this is the function this. It will get this function, then I have to import this class file, or I have to import this functionality, or I have to import this module also, so that it can work. So same way, all these functions are defined inside the data list. Data list is a predefined module, but whenever we are going to import, it is importing as import data list. So before that, I'm going to show you one of the user-defined function. Then I'll go for the predefined function. Here you can see here, I've defined my own model. What you can see there, I've defined my module name. What is my module name is here? What is the module I've defined here?
Geometry.
Geometry. Okay, all of you? Clear? So module I have defined as a geometry. So inside the geometry, what you can see that I have defined a different function names. What are the function names? One is sphere volume, sphere area, cube volume, cube area. Lots of functions are defined. And each functions, you can see that with we are mentioning with a type. Here, sphere volume is defined with a float. Okay, sphere area is defined with a float. Cube volume is defined with a float. Cube area is defined with a float. Cuboid volume is defined with a float. That is, three arguments are there, one at a time is there. Here what you can see that sphere volume is a what? A function name. It's binding what? Having one argument and one return type. We already know this. All of
Yes,
you?
Sir.
Yes.
Yes, sir.
So now here you can see that cuboid means that how many function is having how many arguments?
Three argument.
Three arguments and one return type, and the return type is a float type. Same
Yes.
thing also. These are the functions are defined. Means each functions are defined, and these functions are already defined with its formula. Clear?
Yeah.
So that means what? Now we find out that The geometry is a model, user-defined model. It's a user-defined model that is defined by me or defined by us. We all develop this model. Second part is that now the geometry which is defined by me, I want to share my model with Aditya, with Sonsa, with Ananda, with all of you. Then how we can do it? Then how we do it? This is the model I have defined it. Okay, I just told you that you use this model and run the program. Here, you use this model and run the program. How you do it?
Just import that, right?
Perfect. We have to import this because this is been defined by me. And I want that you all of you use this because I don't want that you have to write the program because till now, whatever we have all experienced people, we know how to write a program. Whenever we are writing a project, before that we are defining our functions so that repeatedly we do not have to write the code within each and every programs. But the main difference is that suppose, for example, that we are using a pi program. The pi value is 3.142. Okay. Suppose now you are all of you doing a project. So in a project you have lots of files are there. So in lots of programs are there. One program you are writing 3.142. Another program you write 3.142. Another program you write 3.142. In suppose you have already written hundreds of programs files. So everywhere, somewhere you have written 3.142. Question arises if day after tomorrow or after some days or after some weeks, that client tell you that no, you do not have to use 3.142. You have to use 3.141. Now you have already written the entire project work. Then what you will do? What is the issue will arise? Anyone can reply because we are only developing the applications. What the issue will arise? Sohan sir,
Updation
this is
problem
a
like inconsistency.
program like
Inconsistency will arise.
why inconsistency will arise? All of you understand it or not? All of you
Yes.
getting my point or not?
Yes.
Are you getting my point? What actually I'm asking the question? Hello.
Yeah. Yes, sir, Professor.
Okay. So what is the inconsistency there? Inconsistency means that whenever the clients ask you to change the 3.14 to 3.141, then you have to stop the entire project. Then you have to sort where is 3.142, then modify it. Okay, so that it should not be any error or any problematic error or any calculation error there. Then after you proceed, it may take 1 day, 2 days, 3 days. Means you have to waste your time. But if you define your model, then I define a constant value that pi is defined as 3.142. And everywhere I have used my constant. Everywhere. If the client defines that, okay, just 3.141, simply I go to the constant and modify that 3.141. So I do not have to go for each and every code of the lines. That means what? Once I modify the constant, the entire project will be modified within a seconds. This is the most biggest advantage of the application. Got my point?
Yeah.
Same way, also we are defining the models whenever we are writing a program. So whenever I'm writing a square root or when I'm writing a factorial or whenever I'm writing a swapping the applications, I define my models within a function or within a class so that I can call the model in any of the program and I just execute it. If some modification needed, simply I modified the model, automatically the entire modules defined in the entire application will be modified. This is the most biggest advantage of a real-time application. We already know it, all these things, okay? Same thing I'm going to define here. Haskell is not in all the languages. Haskell is also having the same programming application. We define our own models. Here I define the model, my name is geometry. I have used it. I have declared the function with types, and the function I'm defining the function here. Okay? Now, once I define the functions, I have defined another program that you can see here that I define name as that. First is name as what? Geometry module.hs. And the second part I am defining here is that geometry main programming. Now, this is the main program. Here I have to call my user defined function models here. So this is the another application. That means geometry module will be the user defined module, and geometry main is using the geometry module, means it is using the predefined module or function whatever defining. So here what I am defining, I am writing the import geometry. Here this is the module geometry. Here I am defining that import geometry. Clear? All of you?
Sure. Yes.
Now what you can see here, I am writing here sphere volume. Now it is a predefined function or user defined function?
User defined.
It is a user defined function, but this function I have defined here. So here I have passed the value from one programming applications, then it will pass to here and it will process here, then it will return the value as a float type, then return get the value here as a one. Now here it is, here we are using this program function, the sphere volume, we are passing the argument value here. Clear? Is what? If whenever I need the geometry, I can use here, I can use here, I can here in this program, anywhere I can use the program. That's why actually I'm going to define that. Whenever I'm defining the models, we always use this concept of model for the betterment of our programs. Now, so here I've written everything here. Okay. Now, so what you have to compile here? In the GCSI, whenever you want to compile the program, you have to compile the program geometry main, then geometry module. Now, how to compile it? Because you are using this sphere volume with the whom? With the geometry model. So here I am writing compiling. So load here, colon L, then
Geometry.
yes. People simply write it. Okay, now I'm running it. Now you can see that it defined that GSI shows that one error. What you can set the error is showing that it is not importing the geometry here because the module failed. Means what? Whenever you are, this is a user defined. So though you are defining the module here, you have to compile this program with this program. You have to compile both the programs simultaneously. Here again a module compiling it. Here. Now, compiling 1 of 2 and 2 of 2. Compile the geometry, then compile the main. Okay, clear? Sohan sir, Aditya sir, clear?
Yes, yes, yeah. So there is no
Yes, sir.
order, right, to compiling these programs? Or
Yes, that will be my second question. First, this is first we will execute. Aditya sir, clear? Vishwajit,
Oh, sir.
all of you got the point?
Followed. Okay.
Okay. Now, second part is that I have to run the program. Clear? Next, I run the program. You are getting the output or not?
Yeah.
Okay, clear? Now you can see that I have to compile the program, main programming with the module programming. The module is first one is the geometry will be compiled. Second, the main will compile, because once the this module, user-defined module will not be compiled. It cannot work of the main module. Okay? Now, question again arises, one of the another example is that. Just I am going to change it. Here, hello. Now I'm writing this one. Whether it will say any compiling error or not? Anyone? Previously I'm writing what? Previously writing what?
Yeah, main
Geometry
module.
main with geometry module. Just I reverse it. Geometry module with geometry main.
I think it
Any
will not give
compiling
error.
error?
I think so.
It will give error.
It will show an error.
Yes.
Okay. Any one? At the sir, output.
I think because there is order doesn't matter that it will take in the first scenario also
My
it
question is that when it will compile the program, it will show any compiling error or not. That is only one answer. If yes, why? If no, why?
I think compiler get that all the precedences here, so no compiler will come.
Okay. Okay, let's compile this. Very good answer. Okay, it's no compiling error. Now suppose I'm going to run the program. So whether it is a runtime error or any problem is there, or let's execute the output. The process now compile the geometry first, then compile the main program. As per the rules, yes or no? Previously define that, compile the geometry main, then we'll get the output. Same also, we just reverse it, then the same geometry first compile, then main compile, then we run the program. So whether it will with the output or it will show the error, runtime error.
It will show runtime error.
Why?
It will not found the module.
It will not found the module. Okay, very good answer. It will not found the module. Because because the modules are defined, because whenever you are compiling the application in which way you compile it doesn't matter. But remember that main first executed, main will be compiling with the geometry module. Here, this is the main concept. Here we have to compile the main module with the geometry module. So then after that, both the case compiler will be processed will be okay. But when you run the main programming, it will first try to run the geometry module, which will not be possible because main is not there. So that's why we have to start it from main program, then execute to the module. Compilation will be in module to main. But when we run the program, it will from main to the module. So compilation will not be error, but in runtime errors, it will show the error. Now, this is the basis concept what we are going to discuss. So important part is that why I am just telling you till now whatever the module are defined. Now we got it that intersphere, interscalculate, script 7, sort. These are the different modules. Yes or no?
Yes.
Clear? So they are defined inside the data list. So here I am, but because data list is already a predefined compiled modules. So that's why we should not compile with both the data list modules coding with this main module. It's not required. But here what you can see that this geometry module is not a predefined compiled module. This is simply a program we are writing. That's why we have to compile both the main and the module simultaneously. That's the reason. Got my point, all of you?
Yep.
Because this part, I am telling you, because whenever we go for to the Protos part, this is the most important part of the programming in the Protos. What to import, what not to import, how to import, that everything we have to write because these are the qualified applications. Okay? Any doubt, anything clear?
Yeah.
Because this part is already we have over model. I just clear the concept. what really module works. That's why I'm just giving the example.
So,
So
Prasanna
same
sir,
thing.
when we execute any program, main program, so it will go, main program will sort that all the modules automatically, right?
Yes, perfect. Because
So,
till now, in Java, in .NET, in C, C++, what you are writing here? We are writing inside the main. Whenever you are writing the main will, because main is such a IO function, it has been defined. The compiler, the interpreter or the compiler will directly source the main module. Because in somehow it has to enter to the function.
yes,
That's why it has been compiled. It has been already passed with the compiler is already passed with that particular model, so that whenever we run from the OS is trying to solve the main model, because main is a function that we actually writing. Because everybody, whenever we are somebody is asking you, main is a what? Everybody says that main is a predefined function. No, main is not a predefined function because the body part we are writing is a user defined. If you're not writing a body part, then it is a predefined. That's already clear it.
yes.
So that's why main is a user defined, because main inside the main we are defining. We are defining the program. So this is the definition of the main program. Main is already been called by the itself. Whenever we are running the program, it is calling by itself from the website. It call the interpreter or the compiler, it will call it and then run the program. This is the basic reason. Okay. Hello, clear?
Yes, sir.
Okay, thank you. Now, so same thing is that another basic, just 1 minute, what the difference between list and tuple? We have already discussed. Already this is, Narendra sir already told this concept. I've also repeatedly told this concept. What is the difference between list and model? Sorry, list and tuple. List contains similar type of values. Tuples contains dissimilar type of values. Both are called the array lists. Okay. Okay.
Yes.
So it is, we are not going to discuss, just I'm asking the question. Okay. Second, going to the map part. Now, what you are going to define here, the map also already part, we have already discussed about map. Now here what I am going to define, what is the major difference between map and a set? Anyone? Map means a key with a value. Map means a key with a value, and map means the value may be a unsorted manner. It is not that it should be in a sorted manner. It may be in an unsorted manner. Okay. And set means always it is in a sorted manner. 1, 2, 3, 4, 5, 6, 7. It is, you cannot write 2, 1, 5, 7, not be possible. Okay. So just I'm asking some question. Now here you can see that here I'm defining two parties here. Now you can see that I'm writing import data.map and defining as a map, and import qualified data.map as map. Here why I'm writing as map? Anyone can say it? I'm not asking about Haskell, because this is that also part we have already discussed. This part data map as part. It is called like allies.
Yeah,
The short
yes.
form of that number. Yes, it is called allies. It's a short form.
Correct.
Means if you not write the entire data.map, simply we write the map, then we can execute. Yes or no?
Yes.
Yes. Okay, fine. Thank you. So now here, what I'm defining here, there is a two-way we are using. One is defining as a qualified, one is defining as a data map. Here what defined that whenever we are using a data map, simply it is a module we are using it, the program. But whenever we are writing a qualified means that particularly been integrated with the GSSI. Whenever we are running with the GSSI will find that whether that particular map is having a different type of modules. Whenever you are using this module, it will define that yes, it has modules, that is called form list is a modules. But whenever you are using the data map dot with a map, it defines that whenever we are defining a map, it should have which type of map we are going to use. It is a integer map. Now just I'm giving the compile the program, I'm running it. Okay. Just wait a minute. Now you can see here. Okay. Now running it. Now you can see that. Here, suppose the from list is a user-defined, predefined function that is called by the map. Okay, here from list is a user-defined called by the map, and it will make the pair with this one. Pair means a function with an array list. Function with an array list. So forget the output because we don't have to think about the forget. Just here I'm going to tell you that whenever I have to suppress this import, just make a comment line. Now you can see here. I'm just giving a comment line. Now I am going to compile it. What you can see that it is showing the fact that map.from list. Just like I told you that whenever you define a qualified option, it is basically using define that this map that aligns the data.map should be required from the GSSI. Whenever you are trying GSSI means this from interpreter it will check that whether that particular map is using its own function and this function is not accessible because this map is not working. Now just I'm okay, I'm commenting the part. See here. Again I'm compiling it. Now you can see that. What you will see that in the top one, whenever commented, qualified say that yes, I have a map and I have the from list. Okay. But here also I'm using the map. Here also I'm using the map. But here the map define that whenever I'm using the integer type, a integer, single integer with a integer array, it define that this map is not defined. So whenever you are not defining, then the from list, the output of this from list, what you are going to get it here, it is defined that no, it cannot make a pair because the type is not specified here. So that means here both the modules we have to use it here to get the output. Now you can see here, both the output we have to give here. So that means we have to import both these modules. Because why I am telling it here, because the same process, whenever we go to the fructose part, okay, there we can understand why you are writing here, what you are writing here, why you are writing here. Then you get to the point from this small programming, we get it that I'm defining my own user-defined map here. Now look here, my map. I'm using a map. We are passing the value 3. Then it will work as a 3 times. 1:1:1 this is them. And here one integer value is there, one array of integer is there. That's what is giving the pair value. It's making a pair. So what pair is, it's not a matter. But the important part is that whenever I'm defining the my pair, it will be defined by the map. Whenever I'm using the map with the value as a passing as a 3, then the map will pass the value to the from list and getting the make pair. Because these two is the most important part what we are going to be discussed in case of fructose. That's the most important part. Anybody any doubt?
No. Clear.
Okay. So this is the basics parts till now whatever we have discussed. Now, just we'll cover another basic parts here that. So we have already discussed about higher order functions. We have already know that. So here also same process we are doing here. So here what means that higher order function is there? Whenever you are using a map itself is a higher order function. Now here what you define that here the function we are using A pointing to B, which pointing that each A element with each array element of B. So simply define that here we are also importing data.cat with importing preluding hiding map. This function, this is the actually this everything is defined one by one. So here whenever we are going to run the program, it will give you the output as the Cardano to mapping as a two upper function. Here is the function is that two upper function. It will convert to the two upper function and get the output. So that is the important part here. We are also using the model here. So all the predefined models, whatever we are using here, we are specifying here every model. That's the most important part also. Same also in case of where clause, this is called as a basically a small programming of polynomial equation. So s squared 2, that means it is the into minus 8x plus 6, whatever output we are giving here. Also we are using the program. The where we are going to use the where class. This is the where class. Okay. So this is the basics part till now we have discussed. Now suppose I'm going to tell you one of the most important part of the programming. Now here another program is there. We are going to that's the part we are going to discuss about. Okay. What is a pragma? Till now, whatever we have discussed, basically we are clear how to define our user models and predefined models and how the predefined models we are calling it and different type of models are there. That's we have to time whenever writing the programming, then we can understand how we are going to use the models. Because till now, program, you have already concept on the language. That's why you can define models as per your requirements. Same also you have to do in the Haskell. It is not a different language. It's also same language with a different syntactical approach. Okay. So now, till now, all are clear? Aditya sir, clear?
Yes, yes, sir.
Soham sir,
Yes, sir.
Aditya sir,
Yes.
all
Sir,
of you?
clear. Sir,
Okay.
voice is something breaking.
My voice is breaking.
Yeah,
Yeah, just wait. Okay, just 2 seconds. Just have to think about it and just think about it. Okay, hello, it's clear?
Yes, sir.
Yes.
Okay. Actually, that's a network problem here. Okay, there is no voice breaking?
It is fine.
Okay, thank you. Okay, now we are going to discuss about the pragma. Okay. So basically, what is the pragma? Basically, in case of Haskell, what you are going to write it, it does GSC supports several pragmas or instructions to the compiler placed in the source code. Pragma do not normally affect the meaning of the program, but they might affect the efficiency of the generated code. Actually, in case of pragma, what we have defined that every programming has its own pragma. Pragma means what? Whenever, in case of the programming language, in C, C++, Java, wherever we are writing there, we are also already using the different type of pragma here. But in case of Haskell, we are using the pragma in this format. Okay. In C also we are using that has it. We are also using the it programming, but also we can define our pre-module programmings, pre-compiling. Has this pragma most important part that pre-compiler. Before compiling it will work. Anybody any doubt? We know anybody any doubt that we know it the pragma? When you define the pragma means it is a pre-compiling, means before compiling it will work. This will be first execute, then after that it will compile. Means we have to go for the pre-compiler. This is the role of the pragma. Means whatever been defined in the pragma, it is automatically executed by the compiler. But some of the pragma is being defined. It will not define the pragma, the compiler will not work. That's the most two important part of the programming language. Now that two part also I'm going to show you how the pragma is working. Because this pragma language, whatever we are going to discuss, lots of pragmas are there in Haskell. Just I'm going to some basic programmings. Because whenever we go to the protos part, that we have to write the pragma. Some of the pragma we may not needed for the programming applications, but some of the pragma is compulsory needed whenever we execute the program. That's the most important. Means pre-compile, before compiling. If you compile the application, if you find that yes, this part is not defined. I'm not talking about import. I'm not talking about any models. I'm just talking about the pragma. And every modules has been defined inside that pragma. The pragma will define that yes, this functionality should work as per before compilation. This is the rules. So here what you define here, that whenever we are going to use any pragma, what that it will not, pragma does not normally affect the meaning of the program. What I'm going to tell you, whatever till now we are doing the program, every program is defined with the pragma. Some may not affect, some is also affected. Now I'm going to give you one example here, but before giving the example, just first clear how the Haskell is handling the pragma. Pragma or takes the form, in case of Haskell, we are writing here curly braces, hyphen, hyphen, hash, then inside the hash, we have to write the word. This is the indication of pragma in case of Haskell. Now, whenever you are, that means what? This is the opening, and this is the closing pragma. Okay. So certain now that here, what are the file headers of the pragma? A file header pragma must precede the module keyword in the file. Remember that what I am just previously told you. Whenever we are going to define any module here, this is the module we are going to call it. What is defined that a file header pragma must precede the module keyword in the file. Means we have to first use the pragma, then after we have to use the module. Okay, so this is the actual process of doing the programming. Now second part is that there can be as many file headers pragmas as you can. They can be preceded or followed by the comments. This is called the basically comment line, because till now we have defined that whenever you are using Haskell, this is a Haskell is a comment line. Okay, but only difference is that here we are using the curly braces, hyphen. This is the comment line, but whenever we can use with a hash symbol, and this is also using this. This is a comment line, but we are using as a hash symbol. Define that. This is called a pragma module. Now, so here now you can see that I'm using a pragma. What is the written here? Here everything should be written in capital letter, language. Now you can see here we have to define this option. I have defined the file header pragmas are language. It should be written in capital letter. Options underscore GSC, it written in capital letter. Include, it should be written in capital letter. Okay, so lots of things are available, but whenever we write it, that it starts with the language. Here, what I'm writing here, I'm writing the overloaded string. This is being defined with the language. This particular pragma is defined as a language. Then when we define it a language, then below that we have to import that data.bytestring character 8 import qualified data bytestring dot AJB. Now what you can see here, I'm using a byte string. What the byte string here? Whenever I'm calling the program here, bytes and str program, here I have to bind it with the byte string. Here I have to bind it with this string. That means what? You can see that the module is overloaded. The string is overloaded with this string. The string I am just an ordinary character. And the string, here the string what is giving the output is overloaded with these two functions. Now what the string I am giving back? Whenever I am printing the print bytes and print the str, it will give the output here. For the output here, I'm just giving a compile the application, then I'll check. So is the output. Now you can see that. What you can see the output? All of you tell me. I am a byte string, not a
Character. Char.
okay. That means what? Data.bindstring.character 8 format define that b.bindstring, the output here, that which type of string it is going to define that. It is defined that no, I am a byte string, not a character. This is the part what I am defining here. But what you can see that the module is what? Overloaded with the b.bindstring. Okay, I just remove it. Bindstring is not required. Again, I compile it. Okay. It's needed?
Not needed.
Not needed. But again, question arises. Then why you have to use it? Because in some of the programming languages, what we are defining that whenever we have to do any operations, it is the basic programming I'm just telling you. Whenever I'm doing some basic programming, okay, then we have to use, just I'm showing you that this language overloading string is compulsory used here. Suppose I'm going to remove that overloading part. Now you can see that. It is showing error or not?
Yeah.
It cannot overload. Just I'm giving one example. That's why I'm just writing this one. This is overloaded. Okay. Now, suppose now here I'm going to show you another part. Now we can see here. Here is another programming called factorial. Here. Now you can see here. What I'm writing here? Fact. What is this written here? Factorial. Okay. So factorial means what you can see here. Factorial means what? Now we are writing the different type factors. Here I'm writing here one factorial. What I'm writing here? The language. What the pragma is written here? Language. What is written here? Tell me. Language. What is written here? Tom sir. Aditya sir.
Postfix operator.
Postfix operator. This is the most important part. What is the postfix operator? Prefix and postfix.
Yes.
What is this difference? Prefix and postfix?
AB plus. Like.
Okay. Okay. Thank you. So that means what? So this is means what? Prefix and postfix, that plus plus, what is the operator we are using? Plus plus x or x plus plus, whatever we are writing here. So in case of data structure also, we are using the postfix and prefix also. So before that, we are going to discuss that. Here, what the symbol I'm using, this is a symbol I'm using, and symbol I'm defining as an integer. So I define that this is a postfix operator that I'm going to use it. Now, this is the only giving the factorial value. It's not a mandatory. Okay. So here the value is needed as an integer to integer. That means what? Here this symbol I'm using here as a n as a value. Suppose n I'm passing as a 4, and here I'm passing as a this symbol. The question is that I'm not using the pragma. Simply whenever I'm reviewing the pragma, okay, I'm going to compile it, colon L, then fact dot fetches. Is there any error? No. So it will give the 24 because I am passing the parameter as what? 4. It's a factorial value. Now, in the previous program, what you can see that whenever I try to remove the pragma value here, it will affecting the program. But here, if you removing the pragma here, it is affecting the program or not, then we verify it. Affecting? It's
No, it
affecting
is
or
not.
not?
No.
No, it's not affecting. Understand?
Yes, not affecting.
Affecting. Just now I have told you what I have defined here. I defined that pragma does not normally affect the meaning of the program, but they might affect the efficiency of generating the code. That is the most important part of the programming. Clear? In some part, we mostly needed the pragma. In some part, we may not take care of it because every program is really defined with a pragma. Pragma means that is a pre-compiled statements. That means already defined here. So we have to use it. Whether we need it or we needed it, it doesn't matter. That's the two different part I told you. Okay? Because pragma is a very big concept. Really, it is a very big concept. So I cannot define within a small period of time. Okay? But we have to follow what is pragma because this is the most important part of the entire programming language. Not C, C++, Java, it's also Haskell also. It is most important part of the programming language. Everywhere, from starting from C to C++ to Java, wherever we can use pragma. It is most important part of the programming language. We have to always follow the rules and regulations of the pragmas. That's why we are writing every program because most of the program will execute without the help of pragma, but it is needed. That's why this is the most important part of the program. Okay? Any doubt? All of you?
Yes.
Here I told you that language we are using it, option GS is using, this is most option GS means whenever I'm interpreting any Glasgow compiler we are using here, this program also used because lots of programs are there. It is not possible to show you hundreds of programmings, but that they are also using. I'm using the language concept. Some part is include is there also. So you have to use part one by one, and somehow in Pluto's also we are going to use also some lots of things pragmas. From there also we get it. Because I told you pragma because most of the pragmas are used in the Pluto's. That's why I told you. Clear?
Yeah.
Okay. Okay. Another just I have to before I'm closing it, just I go to discuss on one of them. Here you can see that I'm writing the factorial different techniques. Here I'm writing the factorial with a norm. Okay. Here I'm writing the factorial with another way of writing the factorial, how to integral part. Here is the another way of writing a factorial. Here is another way of writing a factorial. You can write in different because we cannot say that we can only write in a simple program. Here, this is the called pattern matching we are using here. This is basically what you can see here. It is normally using a list product where we can use the factorial here. Here we are using the if condition where we are using the programming. Okay. Here also we are using the recursive function to use a factorial. We've already done the factorials. You can see that fact, but the norm is a type class. Norm is a
Type.
Norm is a type class. Norm define that, yes, I am defining a type A. So it's pointing to A, sorry, A pointing to A. Here means that it is a pattern matching. You define that whenever you are passing the function, value should be 0 equal to 1. Means whenever the value will be written as a factorial value will be 0, it returns a 1. Otherwise, the factorial will always return n minus 1. Yes, we know it very well. So when you will pass the value factorial x, here is 5. So automatically 5 minus 1, then store. So whenever you get the value as a 0, here the factorial is 0, then it will return as a 1. That means we know that every value stored in a stack form and it will work in a LIFO method because recursive function always work in a LIFO method, last in, first out. We know it very well. So this is the most important part of the recursive function. Now here the same concept we are in the factorial. Simply you are writing the product. Okay. The keyword here the function I am using the product. With what I am writing that? 1 dot dot n. N will be the 5 value. Then automatically it will show the product. And product is a predefined function. It will multiply the value. What the here the value is passing here? Integral A, where value A is a means written out the functional argument will be integer type and return type will be integer type. So here the only one argument is there. Now here you can see that EQT. What is EQ? EQ is also a what? Type class. Okay. It is defined that EQ is always defined with two symbols. That is operator basically is double equal to and not equal. These are the two parts where EQ is defined. Okay. So EQT means what type of equality? Here you can see that I am using the double equal to. So this means EQT. The norm T means it is the numerical value we need it. T pointing to 2 means when factorial n value is that if n is less than equal to 0, normally if in f case we know that then return 1, else n into it's a recursive function factorial calling by n minus 1. That's so here also we can use the if function. And this is called otherwise function, what I have already defined here in the factorial. I just simply define the factorial value. Whenever giving the negative value, it will show the output as a negative value. That is a factorial is error. Otherwise, it will return the value. And here also I am using the pragma concept, what we have discussed. Clear? Anybody, any doubts?
No, sir.
Now, everything we have already discussed, different map, modules, discussions, every part we have already discussed. So this is the complete concept of Haskell. Now, you know that what is the different type of Haskells and how it has been completed. So list, module, functions, then how to make user-defined module, then how to use a pragma, what is map, what is functor, what is monoid, what is monad. Till now we have discussed. Monad means it is simply a function. Monad, what is functor, and what is affiliate functor. Previous classes we have already discussed with the three different classes. What is the major difference between map and fmap? Fmap means functor map. Map means a normal map because functor map is having defined with some predefined data type just like just and nothing and maybe. Okay. So these are the basic parts. Till now we have covered in the Haskell. So we just cover the basic part of the Haskell. So next time we also go for the Protos. Okay. So before I just stop it, just I'm giving one of the most important part of the system programming. Here you can see that system.directory. Simply we can define that whenever you are going to write the directory, you can see that system.directory means it will print the output. That system directory means the directory list. It's basically from system it will get the value at the directory list in which directory we are working. System dir.hs. Now see the list. Here I am taking the drive.backups Haskell final. Here I am using the my username is Asus. Here my C drive user Asus is a document file. So this means that from this directory list I am working here. Clear? This is one of the system directory. System date and time. You can also see the system date and time. Now you can how to see the system date and time. Then suppose system now you can see that here it is showing the date and time. Okay, same system date and time it is also displaying here. This is another program. Simple as small programming. Here I am importing the data.time and here the get current function. It's a predefined function. Okay, of the quiz module, data.time module. So it will be redirected to here. This is basically here what I am using here. What is this called as? What is this called as? We already covered this one, previous class. Tom sir, Aditya sir,
Control outside.
Monad. Forget monad symbol.
Yep.
This is monad. We are using the monad. Actor sir, just remember that this is a monad.
Yeah, I did not join that class. Okay.
Yes, yes, yes.
Yeah.
Satyavasa Sahu sir, got my point. This is a monad. Satyavasa sir.
Monarch.
Yeah, this is monad. M-O-N-A-D. Okay.
Okay.
Another is monad. M-O-N-I-D. That's a different simple functions. So now here we are using these functions. Now this is also same way. We are whenever we are going to get here, what is that? System environment. System environment means in my ways, part of the environments have been set. In the environment variable, whatever the variables are set, it will give us the value from the system and display in the Haskell. Now we can compile this one. Alone L system now you can see that these are the list of system variables which has been set in my system. Okay, clear? These are system variables, and the last one is here we can see the system information. System info.hs. For the system information, what you can see there? Okay, this is S8664 GSC compiler version I am using version Ambrose 9.2 version this is because this is GSC version is 9.2 I am using here and the entire application is running in the GSC version 9.2 and I am using the S8664 my architecture of the computer and we are using the Windows 32 mainly mingling applications. Okay, I'll just forget this one. So this is the message one. Clear? Okay, till now any doubt any is there?
I will take 5 minutes. Everyone dropped. We'll discuss something.
Okay, okay. Okay, you can ping it to the hello. So you can ping in the Discord there we can discuss.
Okay, fine then. Fine.
Okay.
Yeah, fine, sir.
Okay, okay. Okay, thank you. Okay, good night to all of you.
Good night, sir.
Okay, next class we'll go for the Protos class. We'll have a basic discussion on Protos, then we'll start the Protos. Okay.